Hi, in this video we're going to learn about rate of changes and behavior of graphs, the third subtopic of chapter 1, functions. So here we have learning objectives. At the end of this section you can find average rate of change. You can analyze a graph when it is increasing, when it is decreasing, or when it is constant. And we can find local maxima and local minima. Also we can find absolute maximum and absolute minimum. So here we have a table, and here is year. Y is standing for year, and cost each year for gasoline. 1 gallon of gasoline in 2005 was $2.31. 2006, $2.62. So this is money and this is year. And C is standing for cost. If we want to know how much it has changed in 1 year, we subtract this from this, 2.62 minus 2.31. If we want to know how much it has changed in average from 2005 to 2012, then we write 3.68 minus 2.31 divided by how many years? 2012 minus 2005, 7, and it gives us $0.196. So on average the price of gasoline increased $0.196 each year. Average rate of change, we find change in output over change in input. So average rate of change is delta y over delta x. Delta means changes in y over changes in x, and that means y2 minus y1 over x2 minus x1. Outputs over input, changes of output over changes in input. And when we're talking about functions, then we can substitute y with f of. So this is equal to f of x sub 2 minus f of x sub 1 over x sub 2 minus x1. Given the function j of t, find average rate of change on interval -1 and 2. So t1 is -1, t2 is 2. t1 -1 right here, g t1 is equal to, we can write g -1 is equal to 4, and g t2, which is g of 2, is equal to 1. So average rate of change is equal to g t2 minus g of t1 over t2 minus t. It's equal to 1 minus 4 over 2 minus 1, and that's equal to -3 over 3 is equal to -1. Compute the average rate of change of f of x is equal to x squared minus 1 over x on interval 2 and 4. So this one is x1, this one is x2, and f x1 is equal to f of 2 and that's equal to 2 square 4 minus 1 over 2 is equal to 3.5. F of x2 is equal to f of 4 is equal to 16 minus 1 over 4, and that's equal to 15.75. So average rate is equal to fx2 minus f of x1 over x2 minus x1 is equal to 15.75 minus 3.5 over 4 minus 2. So the answer is 49 over 8. Find the average rate of change of f of x is equal to x minus 2 square root x on interval 1 and 9. So x1 is 1, x2 is 9. F of x1 is equal to f of 1 is equal to 1 minus 2 square root 1 is equal to negative 1, and f of x2 is equal to f of 9, which is equal to 1 minus 2 square root 9 is equal to 1 minus 6 is equal to negative 5. So average rate of change is equal to f of x2 minus f of x1 over x2 minus x1, and that's equal to negative 5 minus 1 over 9 minus 1. So it's equal to negative 5 plus 1 is negative 4 over 8 is equal to negative 1 over 2. Here we have another example here. The electrostatic force F between two charges is a function of distance. So when we have two charges, the distance between them is d, then the force they exert each other is a function of the distance between them. And f of d is, according here, 2 over d squared. So what is average rate of change of force? If we take these charges from 2 centimeter to 6 centimeter, so the distance is now 2 centimeter, we take them apart from each other to 6 centimeter. How force changes per centimeter? So d1 is 2 centimeter, d2 is 6 centimeter. So f of 2 is equal to 2 over 2 square for 1 over 2, and f of 6 is equal to 2 over 6 square, 36 is equal to 1 over 18. So average rate of change is equal to 1 over 18 minus 1 over 2 over 6 minus 2. You can see the solution here, and the answer is negative 1 over 9. Here we have another example. Find the average rate of change of g of t is equal to t squared plus 3t plus 1 on interval 0 and a, and the answer is in term of a. So we say g of t is equal to t squared plus 3t plus 1. t1 is equal to 0, t2 is equal to a. So g of 0 is equal to 0 squared plus 3 times 0, 0 is 1. And g of a is equal to a squared plus 3a plus 1. So average rate of change is equal to a squared plus 3a plus 1 minus 1 over a minus 0, and 1 minus 1 0, so a squared plus 3a over a, and that's equal to, if we factor a plus 3 over a, canceling, so that's equal to a plus 3. So on interval 0 and a, average rate of change is a plus 3. For example, average rate of change of the function on interval 0 and 10 is equal to a plus 3, so 10 plus 3 is 13. Here is the solution, and find the average rate of change of this function on interval 5 and 8. You can pause the video and try to solve this problem. So x1 is equal to 5, x2 is equal to a. F of x1, f of 5 is 5 squared, 25, plus 2 times 5, 10, minus 8, 35 minus 8, 27. And f of a is equal to a squared plus 2a minus 8. So average rate of change is equal to a squared plus 2a minus 8 minus 27 over a minus 5. So a squared plus 2a minus 35 over a minus 5. Try to simplify it. A minus 5, a plus 7 divided by a minus 5. So the answer is a minus a plus 7. In this section, we want to learn how to determine if a function is increasing, decreasing, or if it's constant. So we know that from left to right, x variables are increasing. When x variables are increasing, if y variables are also increasing, then we say the function is increasing. If y variable is decreasing, then we say the function is decreasing. For example, here x is negative 4, and negative 16. Then at this point, x is negative 2 and y is 16. So x increased from negative 4 to negative 2, y also increased. So this part, the function is increasing. And this part, we just need to focus on y, because we know that from left to right, x is increasing. So just focus on y and see when y is decreasing from left to right and increasing. So here y is 16, here y is negative 16. So this part is decreasing, this part is increasing. What is local maximum and local maximum? When value of inputs changes from increasing to decreasing, so increasing to decreasing, this is increasing and this is decreasing, from left to right, then that is called local maximum. So this point is called local maximum. Basically the point that is higher level than neighborhood. And if we have more than one of these points, we call them local maxima. So if you have something like this, we have two of them, we call them local maxima. So local maxima is just plural term for local maximum. Local minimum, when it goes from decreasing to increasing, then we have local minimum, this point. So this point is lower than neighborhood, local or relative minimum. And if we have more than one local minimum, like 2 or 3, then we call them local minima. So this is plural term for local minimum. Local extreme, local extrema. So local maxima or local minimum, all of them are called local extrema. And the singular term for local extrema is local extremium. So if we want to show local maxima, here is local maxima. It's upper than neighborhood, this point. So -2 and 16 is local maxima. And this point right here is local minimum. Local minimum. 2 and -16 is local minimum. So here we want to determine local maxima and minima. So this point right here is lower than neighborhood, local minimum. This point is local maximum. This point is local minimum. So this point is also absolute minimum because it is the lowest point. But these are not absolute maximum because this graph is going forever. That's not the end of the graph. So we have absolute maximum and absolute minimum. The highest point is called absolute maximum and the lowest point is called absolute minimum. This point is also local minimum. So local minimum can be absolute minimum.